Find out the maximum sine wave output voltage at 2 megahertz frequency if the op amp slew rate is 10 volts per microseconds. Right. So this is a direct question. So we know that the formula for slew rate, that is delta equal to, generally we will indicate slew rate by delta, and equal 2 phi f times the Vmax, where Vmax is generally output voltage of an op amp. Right. So if you solve this, Vmax equal delta by 2 phi f. So this is 10 by 4 pi, and if you solve this, we will get approximate value is the approximate value of this is around. So approximate value of this is around 0.8 volts. So obviously option will be A. So we have to go for option A.
In sequential circuit, the output at any instant. Okay. In combination circuit, if you see, the output depends only on present inputs because it doesn't have any storage for the outputs. Okay. In sequential circuits, you have memory, so it output depends on past outputs and present inputs. Option is B.
In the above problem, we have to find out the steady state value of the above given expression. That means from the final value theorem, limit t tends to infinite, f of t is equals to limit s tends to 0, s into f of s. But the problem with the above final value theorem is that it is applicable only to the stable systems. That means final value theorem is not applicable to the systems whose poles lies on j omega axis or right half of S plane. For this particular problem, poles are located on j omega axis. Hence, final value theorem is not applicable for this problem. Hence, steady state value is not defined. Question is, we have to find out the Z transform of a given sequence y of n equals to minus alpha power n u of minus n minus 1 along with its ROC. Y of z equals to summation over minus infinite to infinite y of n z power minus n. N equals to minus infinite to infinite minus alpha power n u of minus n minus 1 z power minus n. U of minus n minus 1 is equals to 1, n is greater than minus infinite to less than minus 1, 0 elsewhere. So y of z equals to n equals to minus 1 to minus infinite alpha power n z power minus n. Minus n equals to minus 1 to minus infinite alpha by z whole power n. If we change the sign of n equals to 1 to infinite z by alpha power n. If we include the missing term, that is n equals to 0, then we can write like this: n equals to 0 to infinite z minus alpha power n, which is equals to 1 minus z alpha inverse, which is written as z by z minus alpha mod z less than mod alpha. Option A is true. Here the question is, optocoupler is a combination of. Here optocoupler is nothing but it is a unit of LED and the phototransistor. Here whatever the information we are giving as input to the optocoupler will generate a light from the LED. Again, the output must be in the electrical form. So this light falls upon the phototransistor, which will generate the electrical signal proportional to the light variation as an input to the phototransistor. Hence, the option C is correct.
Question is find out the Laplace transform of a sine 3 and cos 2t. Right. So here the option A and option B and option C and option D are given. Okay. So here we have to find out the Laplace transform of sine 3t and cos 2t. Okay. And if you want to directly solve with the help of this, and it is very difficult, so we can convert this into a feasible form. So we can convert this sine 3t cos 2t into a feasible form first, then we have to apply the Laplace transform, right? So this is our f of t. So we have to find out the Laplace transform of f of t. So we'll get f of s equal to something, right? So before doing that, first we have to apply, we have to go for trigonometry, and we have to recall our trigonometry equations. We know that 2 sine a cos b is equal to sine of a plus b plus sine of a minus b. We know this equation, right? So now I am converting this sine 3t and cos 2t so to in this equation. So right, but here 2 times is not given. That's why sine a cos b. So sine a cos b equal to 1 by 2 times sine of a plus b plus sine of a minus b. That means this equation, right? Now I am converting this. So sine 3t cos 2t equal sine of a plus b. That means 3 plus 2. That is a equal to here 3t and b equal to here 2t. So that's why 3t plus 2t. How much will get? 5t plus sine of a minus b. That means sine t. Now the Laplace transform of sine of 5t plus sine t. We have to find out this. This is equal to Laplace transform of sine ab. So we know that Laplace transform of sine at, Laplace transform of sine at equal to a by a square plus a square. So with the help of this formula, we have to find out the Laplace transform of this. This is equal to 5 by s square plus 25. So here 1 by 2 is there, right? 1 by 2 times, right? 1 by 2 is there. So that's why 1 by 2 times s square plus 25 plus, now the Laplace transform of sine t is what? This will be 1 by s square plus 1. So the option will be 1 by 2 times the 5 by s square plus 25 and 1 by s square plus 1. So if you go for the options, and the option will be here option C. Option C will be the correct answer for this problem. So here first important thing is we have to recall the trigonometric equation, this equation. If you know this equation, the answer will be very simple. Otherwise it is not a simple one.